you. Right, good evening, boys and girls. Today we are going to continue with our civil drawing. I'm going to touch on paper 1, like I did yesterday with regards to analytical question. I'm going to look specifically at the issue of the setup of paper 1, so that this would help you as you answer your questions for the paper 1 for your trial and end of year exam. Right, with regards to that, I'm going to look at the areas that we are going to touch today. We know that when we are looking at civil drawing, we are looking at the floor plan. Right, with regards to the floor plan in terms of civil drawing, we have got the windows, we have got the doors, we have got the fixtures that we need to insert and electrical fittings. And we are also going to do a bit of hatching. Please, boys and girls, do not forget the labels. These are very important. And as you know, with regards to paper 1, especially question 4, all the answers that you require are there, and you are supposed to just check for those answers. I'm going to move on. Right, you now know this statement, and I'm sure you are familiar with it. I hear and I forget. If you simply hear my voice, I'm sure you are not going to be helped much. If you see what I'm doing only and you are not going to do anything, the same applies. That's not going to help you quite a lot. I do and I understand. This is where the gist of EGD is. You must do it in order to understand it. So I'm going to teach you and I'm going to focus on the things that you need to understand so that when you are doing it on your own, you should be able to apply the knowledge that I'm going to impart today. So boys and girls, I want you to pay special attention today so that this lesson will be fruitful to you as you focus on your exams. Thank you. Now we want to get into the real business of the day, which is the completion of the floor plan. Right, as you know that with regards to paper 1, your question 4, it is divided into 3 sections. That is the floor plan, the elevation, and the sectional elevation as well. Right, so today we are going to focus on the completion of the floor plan, putting all the details that are required, and I'm going to look at all these details. I'm going to focus on the doors and the windows. I'm also going to look at the fixtures. Let me just show you in terms of how you would get the marks in terms of the rubric. Right, if you check with regards to the floor plan, this is the area of the floor plan. You have got the doors and the windows. We have got the fixtures. We have got the electrical installation. We are going to look at symbols. We are going to look at wiring. We are also going to look at the hatching technique that is applicable to the completion of the floor plan. Like I said in my introduction, please do not leave out the labels. These are free marks that would aid you in terms of making sure that you get the high score in your paper. So all these today, we are going to look at that, and I would show you how you would attack this part of the question in terms of question number 4. Remember, when you look at question number 4, right, it is basically nearly 50% of the exam paper. As you can see, it's 93 marks. Normally, our paper is 200 marks. So if you get this question properly, you'll find that you would have scored well in your exam. So for today, when we focus on the floor plan, tomorrow we'll look at the waist elevation as well as the section. Not necessarily the waist elevation with regards to this question. Any elevation that has to be derived from the floor plan, we need to see how it is done and how you can go about it in terms of working on it in an examination. My focus, like I said, is to make sure that you are able to face the exam with confidence, with all the required knowledge that you need to have. So let's go straight to the business of the day. Right, now, as you can see from the rubric, I'm going to bring this again. Right, we need to start by looking at the doors and the windows, and that would constitute 13.5 marks. Right, let's start with the windows. Right, you have got the information paper like this. So you'll find that in terms of answering the question, right, I'm not going to read all this, which is at the top from here to there, right? You know, it's question 4, you go down, that's question 4, right? Then you are under the instructions, answer this question on page 6 using the given incomplete floor plan, draw in first angle orthographic projection, and to scale 1:50. So there are certain things that you should be familiar with at this point, the scale and the system of projection. We know that anything that has to do with paper 1, it has to be in first angle orthographic projection. So what is it that you'll be asked to do in terms of this? The complete floor plan. Right, you are supposed to complete the floor plan. You are supposed to add the following features to the drawing, or the doors and windows, which I talked about earlier on as a reflection on the rubric. The fixtures as indicated by the abbreviations, the electrical fittings as indicated by the numbers. We are going to look at that and see how we are going to complete our floor plan. I'm sure you are excited about all this, and if you are happy, I'm happy too. So let's look at now at the completion of the windows in terms of inserting the windows on the floor plan. Let me just set my floor plan in position in terms of the page. Right, we have got 1, 2, and 3, 4 windows. Right, if you check from the information paper, right, you would see that the window next to this part, which is this part, it's window 1. Then on the right-hand side, you have got window 2. Right, on the bottom part, according to our scale, our north point, right, which is this part, then you have got the window 3. So let's start with window 1. Right, which is this one, which we are going to locate here, okay? Right, so we have got window 1, which is supposed to be located there. The first thing that you need to consider in terms of completing or inserting the window, right, you look at the size of the window. We have got window 1, in terms of the width, it's 1,150. That is the width. Then the height is 990, but for now, because it's just the floor plan, we are not worried about the height. We would worry about this one when we do the elevation, when we do the sectional elevation. So for now, I need you to consider this 1,150. Now, you need to have a scale in order for you to be able to measure that. Remember, this is drawn to scale 1:50. What it means basically is every millimeter that you find on paper is basically representing 50 millimeters. So it's a reduction. The size of the drawing is much smaller than the actual object. Right, if you don't have the scale rule, this is what you can do. You take your calculator, right? I would show you how the scale rule would work. 1,150 divided by 50, like that, you get 23. Now, once you have gotten that 23, that is only for people that don't have a scale rule. You go to the space that is left there. You take your measuring instrument, check if it is 23, right? It seems to be slightly bigger than 23. Then if that is the case, what you need to do, you take a 45-degree set square. You take a 45-degree set square. At the point here, the end point of that space, you miter or you draw at 45 degrees faintly, because that's not the answer that we are looking for, but it is the means to the answer that we want. Again, you come to the other end faintly, because the space which is left should be able to fit the size of the window that has been provided. So I'm going to bring this one down like that. Now, if I need 23, right, I would share from here 11.5 and 11.5 that side. And as such, I would have fitted the window in its actual position. Let me do that. This is the space. This is 11, so I go to 11.5, I mark, right? I do the same, which is 23, which would come here like that. Remember, in EGD, the three things which are important, it's your accuracy, it's your neatness, and it's your speed. Make sure you have got those attributes if you are to do well in EGD. Right, then you draw from this point going up. You draw from this point going up. If there is space that has been left in terms of the end point and this end point, you now extend this line and extend that line so that the size of the window would fit the space that is required. Once you have done this, then you need to define the size of the external part in terms of the external seal. From here to there, the external part or the extension from the wall should be 50 millimeters. 50 millimeters would translate into 1 millimeter, okay? So I'm going to measure from here to there 1 millimeter, like that. Then you project like that. Now you have got the basic position of the window in terms of window 1. Then you can even outline from here to there, outline that part, and you can also outline this part. Sometimes you may not need to completely outline, make it slightly thicker than a construction line, but not as thick as an outline, especially the extension from here to there, and this outside one. But because this part defines the wall, you need to outline that part. Right, once you have done this, you now need to position the frame, which means the window frame, right? Remember, the window frame is positioned right in the middle of the wall. I'm going to show you by way of a sketch so that you will be able to see from a much bigger diagram, okay? Right, you have got this, right? Like we said, that's your space. Then this line is already there, right? You have got that. Then we said we mitered, we got that one right in the middle. Right, we measured our 11.5 from here to there, like that. 11.5 from here to there, like that. Right, so if there is space which is left, then you extend this one, let it touch this part, and let it touch that part. Right, in terms of window 1 that we have just defined, there isn't much space that is left. But I want you to note that if you leave, or if you just draw from here and there, you lose this mark and you lose that mark. Then you measure from this point to that point 50 millimeters. Right, remember the 50 millimeters is to scale, which is 1 millimeter because it's 50 divided by 50. The next thing that you need to do with regards to this, you find the midpoint, you insert the midpoint of the wall, okay? Right, in reality, if the scale is big, you'd find that you can even miter to get the midpoint right in the middle, then you measure this way and that way. But you can also use the rule of the thumb, making sure that you have got generally the midpoint, then you measure 50 millimeters, which is to scale, which you can draw like that. Then, like I said, you can outline this part, you can outline this part, you can outline this part, and that part. So this is what we want to achieve at the end of the day. The window in terms of representation like that. We've already done some work, right? So we have got this part, we have got that part, we have got that part. The next thing that you require, like I said, you can use the rule of the thumb, just right in the middle. You draw something like that. You can take your measurement, measuring 2, you measure 1 millimeter, like that. Then you draw right in the middle, like this, just to make it clear. Right, now we have got window 1 in position, and one thing that you should consider in terms of this frame, which is located in the middle, should not be in the middle of this line and that line. It should be in the middle of the wall, okay? Some of you would make a mistake of drawing this right here. Automatically, if you draw that one at the edge, you would lose that mark. So I want you to get this technique right so that you would pass your exams. Right. Once you have done that, you can look for another window, check the distance, and also check the size of this window. Before we do that, this is window 2. Let's look at window 2. From here to there, it's 575. Earlier on, I spoke about a scale rule. This is the scale rule, right? What you see here, from 0 to 1 to 2 to 3, these are meters, okay? So if you want 500, you would get from, if you want 500, you get it from here to there, then 600, 700, 800, 900, and 1,000, okay? So the smaller divisions they are representing 50 millimeters, okay? So we have got 575, right? Let's check with regards to the calculation what 575 would give us. If I would do this, 575 divided by 50 is equal to 11.5, right? So the issue is you check the space which is here. If it is exactly 11.5, then it's fine. You would utilize the space as it is. But let me check and verify, because that's very important. Otherwise, you lose marks. Right, as you can see, from this point to that point, it's about 14 millimeters, okay? So what we need to do is to find the midpoint. Boys and girls, you don't need to struggle with regards to this. Just take your 45 degrees set square at the end at 45 degrees and at the end at 45 degrees like that. This, you will get the midpoint. Remember, our subject is engineering graphics. Our answers should be presented solely, if possible, in form of graphics, okay? You don't want to waste the time dividing, multiplying, this and that. That's not necessary. Get the answer graphically, okay? So from here now, we can now measure. Remember, we got 11.5. Say if we divide that by 2, you are going to get 5.75, 5.75 either side. That may be difficult to measure, right? You can also use the rule of the thumb, then measure just approximately 6 millimeters there and 6 millimeters here, which is 12, right? You won't lose your marks because by now you know that if you make a mistake and the mistake is not more than a millimeter, you are within range. I'm not saying that you should make that mistake, but when you have got dimensions which are very small like this, measure the approximate, which is closer to the correct answer, okay? Right, so in this case, 5.75 is just as good as 6. So I'm going to extend this. I'm going to extend this like that. As you can see, there's space which is left here, okay? That space is the one that you would bring here. You bring this one here, closer to the window, okay? The bottom part, I can see there's no space. I'm happy with that. Then you measure 1 millimeter, the same 1 millimeter in terms of the extension beyond the wall. Remember, we said that extension is 50, so you come here, you measure that. Then you describe this line like that. If you are satisfied, you outline this part, and you also outline that part. There you go. Now you have got the part of the window in place, right? Then from here to there, right? That is your window opening. Then we need now to define the internal and external seal. Remember what I said, right? Roughly in the middle of the wall, not the space. Then you measure your 1 millimeter, right? Again, you can also estimate in terms of the millimeter from here to there, right? Remember, graphics would teach you how to estimate a distance so that when you look at a size, you should be able to judge, okay, and tell. Our eyes are trained so that they are different from the ordinary eye. So that's what you should be able to, if you check this distance from here to there, it's roughly that one. Right, if you are satisfied with that, you move on to the next window, which is here at the bottom. Right, now, what window is this one? Let me check. The window at the bottom there is window 3, okay? Then you go to the schedule, you check for window 3, which is this one. In terms of the distance, it's 1,700, okay? Right, so from here to there, it's 1,700. If you are using a scale rule, like 1:50, that's 1, 0, 1,000, 1,500, 1,600, 1,700, okay? This is straightforward. Then I can easily check there, right? Whether this is 1,700, you can see that it's overlapping slightly. That's 500, 1 meter, 1.5, 1.6, 1.7, 1.8. So it's over by 100 millimeters. So I need to reduce that space. Right, I need to reduce that space, right, from here to there, okay? And how do I do that? Again, you take your 45-degree set square. Very interesting. From the end, like that, you miter. Whenever you want to find halfway the distance, the 45-degree is the most important tool, okay? So here, that's the midpoint. Then I take this one down. There are no special marks for doing what I'm doing right now, right? Like I said, this is the means to the answer, okay? So now we take our 1,700 as it is, 1,700 divided by 50, you get 34. So either side of this line, you have got 17, you have got 17. So let's measure that and see how the space is going to be shared. So I'm going to do this, right? That's 17 this side, right? I mark, that's 17, then that's 35, that's 34, that part, okay? Right, then you bring your set square. As you can see, there is space which is left on the left-hand side, but before we do that, faint line, and also this side, faint line, okay? So there is space that is left on one side, and it's in line with the end of the window on the other side. So once we have gotten that, you now extend this. Please, boys and girls, do not be tempted to just draw the window from here to there simply because that is the space for window 3. Otherwise, you lose marks. Right, okay. Then from there, you now measure 1 millimeter from the wall going outwards, like that. Then you draw a faint line like that. Always start from the known to the unknown. Like I said, you draw faint lines. It's meant to make sure that you are not going to waste the time erasing. Remember, EGD is not about technical rubbing, it's about technical drawing. So we want you to master the art of drawing so that you can answer questions in exams with confidence, okay? So I've outlined this part from here to there, and also this part from here to there, and this part from here to there, right? Then you position your window frame, right, such that you are able to define the internal and external. Remember, the internal is much smaller than the external because of that sloping part, normally which extend beyond the wall. So now we are done with regards to window 3. We are left with one window which is on our left-hand side, which is this part. Right, let's check what window is it. Right, you check here, it's window 3. So it's the same as this window, but also let's check the space. Remember, with our scale rule, right, we can even easily define the space. We said it's 5.7, but as you can see, it's much bigger than that. So what do? Right, you miter faintly. Right, like that. Now I get the midpoint, I can share the space, right? Share the space to the right, share this to the top, and share the space to the bottom. We have already calculated that window 3, which is 34. So I'm going to have to measure 17 at the top, 17 and 34 here. Right, let me draw horizontal lines faintly and faintly like that. Now this, with regards to this window, there was too much space that was left. So if you had just drawn here and there, these lines are going to be positioned wrongly, okay? So don't lose those marks, they're important. Remember, 1 mark plus 1 mark would give you 2. So every mark that is there should be accounted for by making sure that you are doing the right thing, by making sure that you are answering correctly. And this is what we are teaching you, so that you will be able to answer these questions with confidence and accurately. Right, then from there, we extend these lines, the original lines which are there, to the position of the window, like that. You outline. Right? You can also start by construction lines. Remember, time is of essence. 3 things that are important: it's your speed, it's your neatness, it's your accuracy. If you know everything, but you are not going to complete, you are not going to get the marks. If you know everything, but it's not neat, again, you compromise your marks. We outline this part, we outline this part, then we also outline this. At every opportune time, just check again on the rubric side, see what is it that you are asked to do. In this case, you are still on the windows, okay? Right, and these windows, you should be able to get all the marks that are supposed to are allocated there. Right, the next thing that we want to do is to locate the frame, right? Like I said, this you can use the rule of the thumb in terms of position, right in the middle, right? And you can also, again, estimate the 1 millimeter from there. Right. That is the 1 millimeter. Remember, the 1 millimeter that we are talking about, the assumption is that the window frame is 50 millimeters in terms of thickness, right? Some, yes, of course, they could be 32, some could be 25, but the ideal one that we are talking about here is 50 millimeters. So if we have got 50 divided by 50, you'd find that you end up having 1 millimeter. I hope you are following this far, and I hope this is interesting in terms of the lesson itself and the knowledge that you are acquiring, so that you enhance your understanding and be able to answer this question properly in your next exam. Right, I'm done with the windows, this part, this part, this part, and that part. Right, there are no more windows left. So the next thing that I need to consider, if we check again on our rubric part, we need now to look at the doors. Right, let's look at the doors in terms of the information that is provided. We have got door 1, right, which is door 1 here. Right, let me just bring this one down. This is door 1. Right, the height is not an issue at this point, but we are worried about the positioning. So we have got door 1, we've got door 1, we've got door 1, and we've got door 2. Door 2 is the sliding door. We are going to look at that as well. Right, so let's start with door 1. I'm going to make a sketch so that when we draw, you should be able to understand what is it that we are doing and how it is done. Right, normally in terms of the door space, you would find that you have got space like this. Right, let me just extend to the other side like that. I would outline this, I would outline that like this. Right, then you would find normally there's something which you would see, something like that. I would explain that. This is basically the door frame, okay? And when it is right in the middle like that, you know it is wooden, okay? Wooden door frame, right? In some cases, you'd find that they can even put the graphical representation in terms of how we can represent the wood, okay? Like that. Now, if it is not like this, you'd find that this would overlap the walls. The moment you see it overlapping one wall like that, either this side or both sides, you know that would be metallic. But let's not talk about metallic now because we don't have that situation at hand. So this is a wooden door frame, okay? Right, this is how I want you to do it, okay? Right, there are so many ways that are employed in terms of drawing the door and representing it in terms of opening and closing. Right, normally on a floor plan, the door is represented in an opened position. So draw this line like that, right? And also project this line like that, right? At this point, you close, okay? Right, you take your canvas from here to this point, then you describe an arc, right? Then you close that part. Then this is our door. Right, that's our door, and this is the path which is followed by the movement of the door, okay? Right, if it was in loci, we would call it the locus, okay? Right, then this is the door in an open position. So we want to do this setup with regards to our floor plan. Now that we have got an idea as to what we are going to draw, right, we now want to implement that to scale. Right, as you can see, if we start saying with this particular room, I haven't noted which room it is, but we shall going to do that when we do the room designations. Right, now, this part is the rebated part, the rebate and so forth. Right, so you would look for, first of all, check where is the position of the switch if you are going to position the door. Right, if the switch is here, let's suppose we are talking about just a single switch, right? If it is here, which means this position is wrong, okay? Because as you enter a room, you want to quickly access the switch. So if it is here, this would be the right position in terms of the opening of the door. So let's look at the positioning of the switch. Right, I'm introducing this idea of the switch, and I'm making an assumption that you know the switch, you know the line, and so forth, okay? Because we are still going to do that, but at this point, right, like this one, point number, label number one, which is label number one, that's a switch, okay? So what it means at this point, you need to open your door such that you are exposing this switch, okay? Right, at this point, it has no effect in terms of how we open, but here, right, again, the ribbon are on the outside, so the door would naturally open on the outside. It's not going to affect much. Right, where else do we have the switch? We have got here, but this part is going to be a sliding door, but making sure that the part of the sliding door which is able to move is on the left-hand side. So the only part where we need to consider the position of the switch is this one, okay? We shall talk in detail the concept of the switch and so forth, but I thought maybe it was worthwhile for us to be able to know that there is prior consideration that you need to make in terms of positioning the door, okay? Right, I'm going to position this door, right, this way, right? Remember that line that I said you draw, then the other one here, you draw. So you should be able to see two lines, then you close at the bottom like this, okay? Then you take your canvas, you stand here, and you open to the other end. Open to the other end, right? Let me do this. Once you have opened like that, right, you can now describe an arc. This is how the door would open. Normally, in terms of design, remember our subject is about engineering, graphics, and design. As you work on a drawing, you are also evaluating that drawing. You are also modifying that drawing. You are also making it functional, okay? So there are certain rooms that require privacy in usage, okay? Like your bathrooms and your bedrooms, okay? But sometimes because of the nature of the design, you would find that you disregard all that. So I'm going to do this and that, then outline this. Right? Outline that part and also outline that part. There you go. Now I have got my door in position with regards to the bathroom area, okay? Right, you look at this, you'd find in terms of room designation, that's number 5, which is the bathroom, right? Number 5, which is the bathroom. Number 1, which is the bedroom. Number 2, which is the veranda. Number 3, which is the living area. And number 4, which is this one, which is the kitchen area, okay? But like I said, we are going to look at room designations. I just wanted to focus on part by part as you complete the floor plan. So we have got this with door in position. Then, like I said, the switch is going to be here. So naturally, we are going to open it this way. So I'm going to draw the 2 lines. Right, then close this part like that. Then you take your canvas, you stand at the edge like this, open it to the other end. Right, then you describe an arc. Sorry about that. Right, you describe an arc like this. Right, you have got this part, then you straighten it. Unfortunately, I cannot erase that part because I use the permanent ink. so that you are able to see, right? The projector and the visualizer should be able to pick all the detail that we require as compared to a pencil. So I use a pen for drawing to make sure that the lines that we present are visible and you are able to see clearly. But I'm sure you still be able to see this is the description of the door. When your paper is marked, they would check for this, they would check for that. So this is 1 mark, 2 marks. Remember, every line that has a meaning in drawing is credited with a half a mark. In some cases, yes, you'd find that it would be a full mark, but rarely you'd find it's just half a mark, half a mark, half a mark, half a mark. Right, I'm done with this door, I'm done with that door. Right, let me go to the one at the bottom. Right, in this case, right, I would extend this one on the outward because the rivet is on the outside. Close this part. Then take your canvas. Right, describe like this. You describe an arc. Remember, your arc should be visible. Right, then you close here. Right, you have already closed at the bottom. Like that. Now, we have got this part. That's our door, okay? Right, there's one thing that you should consider in terms of the door which is located on the external wall. Normally, you should provide a line like this. Boys and girls, what do you think that line is for? Right, as you enter the house from the veranda or from the natural ground level, right, there is a step up. As you exit, there is a step down. So that line is representing the step up or a step down. Yes, of course, you'd find that in some cases, that line, as long as you are now at the veranda stage, the level is basically the same. But still, in some cases, you'd find that the levels are different. Just to be on the safe side, as long as it is an external door leading to the outside, draw that line. In case it is allocated a mark in terms of the rubric. Right, we are done with this door, and that door, okay? The next thing that we need to consider now is the door which defines our sliding door, right? If you check with regards to the information that we have, if we check with regards to the information that we have, right, we have got this is our sliding door. This is our sliding door, right? It says to fit, okay? Right, so the sliding door should be able to fit this space. But how do we draw this? Let me sketch again. Let me sketch again in terms of how we draw the sliding door. Remember, there are so many ways, right? But I'm going to teach you one method that I think is useful and it's easier to understand. Right, you have got the position of the wall. You have got, again, the position of the wall. This is the space which is in between. Right, we need a midline here, okay? So you miter there at 45 degrees. So every time you hear me say miter, I'm urging you to use a 45 degree set square, such that we don't need to measure from here to there or from here to there. We simply can draw like that. That is the line which is roughly in the middle. Then once we have gotten this line, you measure 50 millimeters. If we are using scale 1:50, let me just outline this like that. Let me outline this like that. Right, let me hatch. We shall look at this, but because I want to illustrate a point, I'm going to introduce this concept early, okay? So this is the midpoint. You measure from this line 50 millimeters to scale 1:50. It's 1 millimeter. The other side as well, 50, like that. So you've got two lines, 50 and 50, okay? Which is 1 millimeter and 1 millimeter, okay? The other thing that you need, again, right from this end, you miter like that. you get that midpoint, right? We know that if we check with regards to our sliding door, the left part is the part which moves, the right part is the part that is fixed, okay? Right, so the part that is fixed, right, should be fixed to the wall, and the part that is not fixed, which is moving, should be slightly away from the wall so that we can see the element of movement in terms of the parts of the sliding door. So the left part here, we can take the inside one, you can take the outside one, then you fix this one again, like this. Right. So this is the part that is fixed. It does not move. Technically, we refer to this one as X, okay? Right. Then you measure, say, 10 millimeters this end. The moment you measure from here to there 10 millimeters, you also come to the center and also measure 10 millimeters as an extension. Why? So that we know that this part, if it is pushed from the right, it can go back in position and the door is closed. So I'm going to do this, right, like that, right. Now, that is the representation of a sliding door in an opened position. You'd find that some would draw this one in a closed position. Again, it's fine, it is acceptable, but I prefer this one simply because you are able to see how the door would open and which part exactly is opening and which part is fixed. The part that is moving, right? Normally it is denoted by a letter O like that. So I want you to take note of this so that you can also apply as you answer your question, okay? Right. Not only that, you'd find that you would also need to show by way of direction, right? It's moving from left to right, okay? So we have said that this is the fixed part from here to there, then this part is the movable part. And to show that it is the movable part, denote by letter O. To show that it does not move, not denote that one by letter what? X. To support that, you show by an arrow like this. Right, so let us go and do exactly what I've explained on my sketch. Right, as long as you are not able to apply it on the real paper, right, that knowledge that you have acquired may not be enough. So you need then to apply. Remember, even if we were to ask someone to draw a pentagon, anyone would be able to draw a pentagon, but very few people like you would be able to draw a pentagon which is regular with equal sides. So that is the difference. Someone can just sketch and so forth. This is a sliding door, but we want that put to scale and on the drawing. That's where we would check the understanding of a candidate. So I'm going to miter this, just one side, it's enough. And also miter there, okay? Right, then draw a line like that all the way, right? Should be right in the middle, right? Slightly offset, right, but that's fine. Then once we have done that, you measure 50 millimeters this side and 50 millimeters that side. Remember, there is no way that you'll be able to measure 50 from here to there unless you put that 50 to scale. So do not lose sight of the scale. It's critical, okay? Right, you measure 1 millimeter at the top and you measure another millimeter at the bottom like that. Then you draw faintly. In case you make a mistake first time, faintly like that. But remember, in EGD, we talked about the issue of accuracy. You don't have time to make mistakes, right? Let me just extend this miter like that. We need it. And to the other side, which is the other part, like that. You need that one as well. Then you project like that. Right. So now we are able to see the top part and the bottom part. Like I said, you can decide to say, okay, let me open from here. right, like that. Then close this part. Right. That's my fixed panel in terms of the sliding door. Like I said, you can denote this one by letter S. Right? Then you measure. You measure from the end. You can even measure 5 millimeters like this. Then you, beyond the halfway, you also measure 5 millimeters. If these measurements are correct, are not the same, then technically it's incorrect, okay? This measurement should be the same as the extension from here to there, such that we can really tell that the space that has been moved from the closed position to the opened position is the same. Then you outline this like that. You outline this like that. Then you can close this part and close this part like that. Boys and girls, you can see now we have got a fixed panel, we have got a movable panel, and we said you can denote this part by letter O like that. The next thing that you would require, either from the outside or the inside, you need to show by way of an arrowhead, okay? Right, don't waste your time trying to create a very complicated arrowhead, just a faint line, and you thicken it at the end. It's enough, okay? Right, the other thing that we talked about earlier on, to say as long as there is an external door, you can also draw a line from one part of the wall to the other like this, okay? Right, unfortunately, it's interfering with our movable part, but at least the idea is to have a line from here to there, okay? That is the step up and step down. So make sure you consider that. Now, in terms of the first part, we no longer have any doors to fit. The doors and the windows are now in position. Now we move on to number 2, which is the fixtures, okay? Right, we want to look at the fixtures. Right, we want to look at the fixtures. Right, you have got that information on your paper, okay? These are the fixtures that we need to use. Right, we have got the water closet, which is normally referred to as the toilet. We've got the hand wash basin, we have got the shower, we have got the sink. So we want to put these fixtures, right, in the respective rooms, so that that room would function according to its purpose. Right, the first one, if we check in terms of, let's look at this. That's the shower, right? The shower here is given like that. Right, normally you'd find that the shower is, if this is 1,000, the other side is also what? 1,000, mostly in squares. But nevertheless, we have got the setup like this. So you need to check which would be the appropriate orientation or positioning for the shower, okay? Without taking too much space unnecessarily, okay? Right, so we can look at this in terms of the space, we can position it like that. Right, let the longer side be this one, from here to there. And what is the longer side? It's 1,000, okay? Right, 1,000, it's a straightforward measurement. If we are using scale 1:50, go to 1,000, which is this one. So I'm not going to divide. I'm going to simply measure from, this is 1 meter from here to there, okay? Then mark a point like this. Then you draw a faint line, okay? Right? So from here to there, that's 1,000. Right, if you want to verify that, you can do this 1,000 divided by 50. You'll find that you get 20. So let me take an ordinary ruler and check. So the distance from here to there should be 20, which is exactly what we have. So when you have got a scale rule, it's fast because the measurement, the graduations are there in terms of application. You are not going to divide, you are not going to multiply by anything, it's already available. Okay? Right. And let's look at the width, right, from here to there. If that information is not given here, check on the other view. Remember, this is first angle of a graphic projection. What you see at the top there, it's your elevation. What you see at the bottom, it's your top view. Okay? Right, so from here to there, it's 850. I can use a scale rule for that. Just check if you are using the correct scale rule. Right, that's 500, 600, 700, 800, 850. Right, remember what I said, the smaller part would give you the 50, okay? Right, again, I want you to verify, right, 850 divided by 50, you get 17. So we should be able to get the distance from here to there equal to 17. Let's check. Which is exactly that. This is 10, 15, 16, and 17. Right, okay. So now I've given you an orientation in terms of how the scale rule is applicable and how you can quickly draw your views. Right, you come here like that. That is our shower in position, okay? Now, what is missing if you check on the top view, right? There is this part, we refer to this one as the drain, okay? And in most cases, the drain is diameter 50. So you draw, if you say 50 divided by 50, you get 1 millimeter. So 1 millimeter, it might be difficult to draw that 1 millimeter as a diameter, okay? So in situations like that, where you have got very small circles, you can do that freehand, okay? So you can position your drain somewhere here, right? Roughly diameter 1, okay? Right, so that, forget about these lines, the drain lines and so forth. They are not important, right? You won't get marks for those lines. What is critical is this line, and that drain point. So we are done with the shower, okay? Right, you get 1, 2, 3, which is 1.5. Right, then from here, you have got the space that is left for the water closet, okay? Remember, the water closet, in most cases, it is directly in front of the window, okay? Right, for purposes of extracting unwanted smell from the room, so you'd find that it is there, okay? Right, now, what I would urge you to do, you have got the space from here to there. Then you extend this like that to that point, right? Fortunately, it's in line. So what it means, this line is actually in the middle. So you come here and just extend it like that. Right. What are the sizes with regards to our water closet? Remember, we are talking about the top view. Hence, we take the view that is seen when you are looking from the top. The overall height or the overall length is 700. We need to consider that. 700, I'm going to use my scale rule. There you go. Right, that's 500, 600, and 700, okay? Then you project like this. You project like that. Right, so from here to there, it's 700. And if you check the width, from here to there, it's 400, as seen from the front view. So from here to there, it's 400. So you are also going to measure 400 again to scale, right? Which is your scale rule. I'll take my scale rule. Sorry. Right, from here, that's 2, 4, which is 200. The other side, 1, 2, right, like that. Okay, then bring this one down like that. You bring this one down like that. Right, remember, I'm taking my time explaining all these concepts so that you understand fully, okay? Right, there is no benefit in us just rushing through the steps if you are not going to understand. So even if we are not going to complete this floor plan, we would take over, we'll carry on with this tomorrow in terms of the floor plan, so that when you face question number 4, in terms of the floor plan, you are able to complete that with confidence. Okay, right, so we have got that part. So at this point, I can outline this and outline that part. Connect to this end like that. But I'm not done with regards to the water closet. There's still detail which needs to be added. Right, it's from here to there is 200. From here to there is 200, okay? Right, we considered 700 first, which is from here to there. We considered 400, which is the width from here to there. We now consider 200, okay? You don't know about this way of drawing. These are stencil drawing, or they are computer-generated drawings, okay? Right, so you know your job is to present hand drawings, okay? So you are going to draw according to the specifications which are given, disregarding the shapes that you see here, only the overall sizes that are appropriate. So I'm going to measure from here to there 200. Up to this point, that's 150, correct? Right, I draw this line, then I outline like that. Right, so if your paper is marked, they would check for this length, is it correct? Yes. If this distance from here to there, is it correct? Yes. The distance from here to there, is it correct? Yes. So you get a mark for this, a mark for that, a mark for this one, okay? Depending on the marking scheme. In some cases, you can be even given these other marks and so forth. Right, so we are done with the water closet. Boys and girls, because of time, I'm going to illustrate the hand basin, then the other details. We'll do that together tomorrow in terms of completing the floor plan. Right, let me check with regards to the hand basin. Again, you look at the top. Right, what is the overall size? In this way, it's 400, and this is 500, okay? Right, this one you can position anyhow. As you enter the bathroom, you have got this space, right? So I'm going to measure 500 there, right? I'm going to consider 400, right, from here, but that's 1, 2, okay, this is my 400, like that, right? Then draw a line, faint line, draw another line, a faint line. If you are satisfied, then you outline this, right? You outline that, okay? Right, we have got our basin in position, but if you check closely with regards to the basin, there's also a drain. Let's factor in that drain as well, which is the part which will drain away wastewater from the sink, from the basin, and so forth into the sewer line. So if you check on this one, it's right in the middle, right? So you are going to come here, draw nice freehand, something like that. You have got this line, that line, and the drain, okay? This should be approximately diameter 1 to scale. Remember, we said it's 50, but to scale, that would be diameter 1. Right, okay? In terms of the fixtures, that is my desire, just to complete the fixtures. We now have got the sink, which we're supposed to complete here, so that when we carry on from this tomorrow, we are going to look at the electrical installation, the hatching, and the labels. So I'm going to show you how that sink is going to be positioned. Right, we have got space from here to there. We have got the size of the sink from here to there, which is 500. Let's check what is that size from here to there. Right, it's 12. Right, and the one which is here, if we are going to use 1:50, 500 divided by 50, we are going to get 10. So we need to position 10 here and from this point and that point, right? From here to there, 10 millimeters. So if the space is much bigger than we want, okay? So what we're going to do, let's miter to get the midpoint. Let's miter to get the midpoint. There you go. That's the midpoint. So either side of this line, you measure 5 millimeters, 5 millimeters. Let's do that. Let's do that. So it's 5 this side and also 5 that side. Please, the issue of scale is important. Whatever you do, make sure you are drawing to scale, okay? Right, so from here to there, that's 10 now, which is actually the size of our sink from here to there. What is the length? The length is 1,200, okay? So stretching from here to there, 1,200, how many millimeters are we talking about? 1,200 divided by 50. We are talking about 24, okay? Let's see if we have got 24 here, right? It's about 27, which means the space from here to there is much bigger, okay? So what I want you to do, again, you do the same thing, you miter in order to get the midpoint, right? From this end, and this other miter is already there, then you do this. Right, so this is the midpoint. Either side, we measure 12, 12, okay? So I'm going to measure 12 this side and another 12 this side, which is our 24, like that, right? Like this, like that, okay? So from here to there, that's 24, which is representing 1,200. So I can outline from here to there, okay? From here to there, right? And from here to there, and that. Basically, that is the frame of our sink, okay? So from this point to that point, from here to there, and from here to there, that is the frame of our sink, okay? Now, but there's also the bowel that we need to consider, right? In most cases, you'd find that in terms of the position of the bowel that I'm talking about is this one, okay? Right, and it also has got a drain. So we want to factor in that. As you can see from here to there, it's 400 on the width side. We've already measured from here to there 500, from here to there 500, right, which is 5, So we are going to measure 4 now, okay? 4 millimeters, which is 400, and 4 millimeter this side, which is another 400. Then like this, like that, right? Then at the end here, right, you can easily miter. The miter is already there, so you do this, right? That is the end, right? How wide is that? It's 450. Again, you don't need to waste the time. You take your scale rule. Make sure you're using the appropriate scale, right? 1:50 is this one, right? So from this point, we need 450. Right, that's 1, 2, 3, 1, 2, 3, 4, 450. Just before the halfway stage, then you draw that. This you can now outline from here to there and from here to there. And you close this part. You close this part like that. Right, our sink is taking shape. The only thing that is left now is the drain, which is this part. Then you are going to insert it freehand because you cannot draw that circle, okay? So when your paper is marked, they want to see this drain part, they want to see the bowel, they want to see the profile of the sink. Forget about these lines, right? If you have got time, yes, you can show them, but they are not necessary, okay? What is necessary is this drawn to scale? Is this drawn to scale? Is this part drawn to scale? Did you factor in the drain? If you do that, you are sure to get all your marks. Boys and girls, for today's lesson, let's end here. When we meet tomorrow, we are going to complete the electrical installation, we are going to complete the hatching, we are going to look at the labels. Time permitting, we are also going to look at the section before we look at the elevation. Thank you.